The first step in this process of adding context is to create a map. D3 has some of the best geo capabilities out there and is one area where it really shines. While you can create charts using other libraries, you would be hard-pressed to find another tool that makes creating data-driven maps as powerful and fun. We will start simply and build up by applying knowledge we have already learned to create our interactive map. The first step of which is to simply acquire data to draw map, which we can then plot the data we already have, the attendance data for the World Cup. Historically, working with maps has been a bit cumbersome since the files you need to work with are usually large, complicated data formats, such as shapefiles or other proprietary formats. The reason being that shapefiles typically encode a lot of data when you think about it. If we wanted to draw a map of all the countries of the world, we would need exact boundaries of every country as a series of paths or coordinates. A few other formats have emerged, somewhat hand in hand with D3, two of which are very related, GeoJSON and TopoJSON. When working with web technologies, JSON can be thought of something as the lingua franca and acts as a common interface between libraries, languages, and technologies. Almost every programming language and environment has facilities to work with native JSON in some form or another. And especially when working with D3 and JavaScript, JSON is the most natural format. So when working with maps in D3, it seems only natural to use a JSON-based format to encode the coordinates you need to display. And that's exactly what GeoJSON is. One issue with shapefiles is that they encode their information in a binary format, which isn't readable by a human unless you use a special program to interpret the shapefile. GeoJSON, on the other hand, encodes very similar coordinate information using valid JSON with some minor extensions, and it results in much more interpretable and human-readable and inspectable data. One very nice feature of GeoJSON is that it's very easy to explore and debug using many of the common development tools, such as simple text editors, or even in the browser console. One of the issues with GeoJSON, however, is that to achieve these features of being valid JSON and human readable, the data file itself is often a bit more verbose and substantially larger than a binary shapefile. And since often when building maps on the web, we need to send this information with any web request, for our graphic, it can put a strain on both our server and the browser and increase loading latency. And one of the final issues I want to go over with shapefiles is they can have some storage limitations in the number of properties you can attach to given shapes, such as names or other data, and shapefiles are limited in their maximum file size, limiting how precise the coordinates and the shape of the map can actually be. The third data format that we didn't cover, TopoJSON, is an extension to GeoJSON that's actually much smaller than both GeoJSON and shapefiles in raw file size, but also encodes topology, hence the name TopoJSON, which shapefiles and GeoJSON unfortunately cannot do. For the sake of simplicity, and since we won't be using a whole lot of topological information in this lesson in class, we'll be using GeoJSON, which in many cases is good enough.